Welcome to the video lecture series on finite languages and automata theory. So now today we'll be discussing about the various problems which is concerned with finite languages and automata theory. So problem number 1, prove the language L equal to a to the power of n, b to the power of n, where n greater than or equal to 1 is not context free. It's not context free language. Okay. Now to comprehend this problem, you have to take a value called as n, a positive value called as n. So let us assume a maximum value called as n. Let us assume that n is equal to 4 and this n is called as a pumping value. It is called as pumping value, or otherwise it is called as pumping constant. So when you take it up, the string is called as s. String is called as s. The string will be, when n is pumped as 4, you will get 4 a's and 4 b's. We'll get 4 a's and 4 b's here. So the rule is the length of s, that is the length of s, should be greater than or equal to the pumping constant called as n. Now what is the length of s? So length of s is a, b is greater than 4. So length of double ear trip 4 a's and b's is 8. 8 is greater than 4, so the constant is correct. Now whatever the value you have taken is correct. Now the next step is you have to divide s into 5 constants, that is u, v, w, x and y. You have to split up the string into 5 different portions. Now I will take it up. U, let us assume that u is equal to a. V is again a. And w is also a. And x is again a. Now we will take y as b. So when you put together, you will get a string called as 4 a's and 4 b's in an order. But the condition number 1 is the length of vx. That means the length of v and x should be greater than 0. So now we have taken v as a. So length of a, and x is also a. So obviously a is 2. So 2 is greater than 0. So equation number 1, condition number 1 satisfies. So we can proceed. Once if condition number 1 satisfies, you can proceed. If it is not, you are not able to satisfy the condition, then you have to reassign the values once again. Now in this case, both the conditions are satisfied here, so you can proceed. Now step number 2, that is constraint number 2, the length of v, w and x. The length of v, w and x should be less than or equal to p. So p is nothing but the pumping constant. In other sense, we have taken pumping constant as n here. So that means v, w and x should be less than or equal to n here. Now what is the length of v? So we are taking it as a, w is also taken as a, and x is taken as a, and 3 a's is less than, what is the value of n? N is called as 4 here. So 4. So 3 is less than 4. So condition number 2 is also satisfied. Now what we have to do is, we have to perform iteration now. So step number 3 is perform the iteration. So how to perform the iteration? So we try to prove that u v to the power of I, w, x to the power of I, and y does not belong to a language. We have to prove that it does not belong to context-free language. Now we'll take up I equal to 2. So case I equal to 2. We'll take case I equal to 2. That means you know what is the value of u. U is called as a here. So a. V is also called as a, but I is substituted as 2 here. So it will become a squared. W is called as a. X is again a. Here a to the power of I, that is a squared now. Y is b. Now when you try to abbreviate it, a squared is expanded as double a, again a squared is, and again does not substitute language. So we can say that number of a's is not equal to number of b's, hence context free language, hence it is not context free language. So thanks for watching the video. Have a good